morning, good afternoon, good evening, wherever you are, dear colleagues, dear viewers. Thank you for joining us today. This is one of the Asgardia webinars, which informs you about the progress of development of Asgardia, the first in the world history space nation, founded by Dr. Igor Ashurbeli. As I'm sure you all know, Asgardia is working to achieve birth of the first human child in space in the next 25 years. In order to achieve that, we study the main three scientific areas. Those are artificial gravity, radiation protection, and human embryology. Today with me are Professor Dr. Floris Woutz from the University of Antwerp. He is one of the most prominent scientists in the world in researching the brain of the astronauts. This is also not just by Google Scholar. We found out recently that actually ChatGPT thinks that way. And this day and age, if ChatGPT says that, that must be really true, not that we doubted it before. And Dr. Sergei Ponomarev, who is working for the Institute of Biomedical Problems in Moscow. This is the most historic institute which is leading in the domain of studying human physiology for the benefit of long-term space exploration. Dr. Ponomarev is the director of Sirius program. Sirius is a series of isolation studies where mixed gender crews are staying in isolation for lengthy periods of time. Today we're here to talk about Sirius-23 experiment, which is ongoing right now. If you follow our news, you know that an Asgardia crew member, Dr. Ksenia Orlova, is a member of this 6-people crew where there are 4 females and 2 males. As part of human embryology study in space, the crew of the Sirius experiment are conducting research in female health in long-term isolation, simulating interplanetary spaceflight. Therefore, today we are going to discuss the progress of the Sirius isolation experiment, especially because they've just passed the equator. 6 months. The entire experiment, as I'm sure many of you know, is going to last for the full 1 year from the 14th of November 2023 to 14th of November 2024. 14th of May was exactly 6 months. Would you believe it? We've just recently spoke in the same group 5.5 months ago about the start, wishing success to the crew. Today we're celebrating halfway through. So first, of course, I would like to ask Dr. Sergei Ponomarev to say a few words, because he is really keeping his hand on the pulse of everything that is happening there. Sergei.
Thank you very much, Irina. So yes, indeed, 6 months, it's a really long time, and we have conducted a lot of experiments in different branches of science. As you mentioned, of course, childbirth in space is a very challengeable task in our opinion, and we need to have a good preparation to this extraordinary event. First of all, we need to know the adaptation of female body to different spaceflight associated factors, including isolation. And so I would say, of course, the condition of different physiological systems. So we need to know what happens to the body, and then, of course, to minimize all risks that could be connected to this event. So first of all, I must admit that in previous experiments and in this experiment, we study immune system, neuroendocrine system, and I would say that there are some changes. Being an immunologist, being head of laboratory of the immune system physiology, I can say that we observe the decrease of immune system function both in innate and adaptive immunity. And if we speak about childbirth in space, of course, this could be a problem because when we, I would say, of course, lack immunity, and we have some microflora that could be not even pathogenic microflora, but the consistent microflora on human body, it could cause severe disease. So that's why we need to implement some countermeasures And if we talk about again about childbirth, so we need to prepare properly the immune system to this event. Also, we need to prepare the neuroendocrine system because we also observe some changes in this system. Conducting isolation experiments where we fancy confinement, hypodynamia, artificial environment. We can do a lot of things on this way to make this event make it possible and to make it safety for the woman and for the child, of course. In this experiment, we have 4 female crew members and 2 male crew members. We then, when we conduct the whole experiment, we will combine the statistics with the previous missions of Sirius project and probably with the data from other isolation experiments, as well as the data that we can obtain from the ISS and from different other ground-based analogs like dry immersion. So we need to know everything about this. And in my opinion, now the time of records has already passed. Now we need to prepare for sustainable life in space. And of course, if we talk about the interplanetary flights, I think that it's very important to think about childbirth. And unfortunately, we have at the present moment we have not so good engines, not so fast rockets to deliver a human being to even out of our solar system. So that's why we need to think about this event, and maybe future generations can reach different other stars. And now we prepare to this event, and also we prepare in this event to this event in our isolation experiments. Because it's a very good platform for minimizing all risks that could be connected to the real long-term interplanetary mission. And the goal of all these experiments is to collect more data, to aware of all hazards that could reach us during this long-term and very dangerous mission.
It's nice to be able to talk about going beyond the solar system, but for now, let's stay more realistic. Of course, the immediate goal of Asgardia is to have what we call Asgardia National Arc, a station with artificial gravity at low Earth orbit. The next will be a cislunar orbit station, and then what we call Asgardia Star Arc, an interplanetary station, yet staying inside the solar system. Indeed, as Dr. Ponomarev just said, we are aiming to achieve birth of a human child. For this, the experiments related to female health are being conducted. Sergei, how are we doing with these experiments? What are the intermediate results? Are they meeting the forecast hypothesis of the scientists? Are there already some new findings which we couldn't anticipate?
I wouldn't say that there are some findings that are not anticipated during this experiment. We are on the halfway, and we still need to analyze the data after the experiment. We usually analyze data on the completion of the experiment. It's much more convenient. But of course, we have some preliminary results. For instance, being immunologist, we also conduct some experiments in the interest of Asgardia space program, I would say, in our experiment. And of course, we also think about how to interpret this data and to combine it with the other experiments. So we have, I would say, same results as we have in the previous missions. We have some decrease in different parameters characterizing immune system, especially if we talk about the immune system function. So it's interesting that we can observe sometimes increase of some population of cells during the experiment of some parameters. But in generally, we can observe the lack of function of lymphocytes, which are the key cells of the adaptive immune system, which are producing cytokines, which helps us to defeat some viruses, for instance, and to start the immune reactions, and as well as we have some decrease in immunoglobulins during the experiment, which helps us to protect human organism from bacteria, from viruses, and from other pathogenic agents from the external side. So, but as I've told you, each experiment sometimes bring us some surprise, some results, but all the data will be analyzed after the whole mission. And I think we could arrange a webinar about this and talk later when we analyze all the data that will be obtained during the 1 year mission.
Oh, that I'm sure we will do, and I also hope we will make a live event in Moscow like we did last year after Sirius-21. That was, I think, an excellent event, also with the crew and with the previous Asgardia crew member, Dr. Kirichenko. Flores, you are one of the most experienced people in the world in conducting human physiology in research in space on astronauts and cosmonauts. Please give us your view how important it is to conduct ground studies in long-term isolation. How did it help you to build your space program?
Thank you, Elena. Very intriguing question. I think they both go hand in hand. We definitely need space experiments in the ISS, but they are very lengthy and very costly, and we can do a lot of ground-based studies which are at least a bit more feasible in numbers, number-wise. Okay, Sirius is a very complicated experiment because you have isolation of 1 year, which is definitely a big challenge. But it are now 6 people who are in this isolation experiment. And so far, as I can recall, there are not too many people who have stayed for 1 year in space. There are a few like Mikhail Kornienko stayed 1 year in space, and Scott Kelly also stayed one year in space. But this, the last cosmonaut actually who had unfortunately stayed 1 year in space because the spacecraft had an issue. So, but that's only 3 people. Now we have in one experiment 6 people on ground who stay in this isolation situation for 1 year. So we can do a lot of more experiments. Obviously, they are very well, they're not exactly the same, but a dry immersion, like Dr. Ponomarev cited, is a fairly good approach of weightlessness and particularly supportlessness. And one of the founding fathers or mothers is definitely also Professor Inesa Kosovskaya, who was very important, who played an important role in this dry immersion experiment several years ago. And now the world is following these examples, which were actually initiated in IMBP in Moscow, because it appears to be a very good model. So like, for instance, MEDES in France, in Toulouse, they have implemented the same model, dry immersion, compared to bed rest studies. Bed rest study, head-down bed rest study is also a very widely used model where people are kind of like inclined with the head 6 degrees below horizontal, and they have to stay in this situation, for instance, like now in the Toulouse experiment and in the Planeta experiment, which is going to be planned soon. They have to lie there 60 days. So 2 full months, just every single moment of the day, they have to lie down with their head, even for washing, for going to toilet, for everything, for eating, for anything. And that's also a very interesting comparison with space flight. So if you combine this type of experiments, when you combine it with dry immersion, you combine it with isolation experiments, you can suddenly start look for many more people and try to extrapolate. For instance, the experiment in Toulouse now has just finished, and it has 24 subjects which have been tested for 2 months. And we investigated how the brain is reacting before, during, and after this experiment. And actually, 1/3 of the people were also centrifuged during this every day during this 60-day period, which is actually implementing this concept of artificial gravity in the whole picture. what I think was a direct question to Sergey is actually the fact that you said the immune system has been deprived and challenged, even in the ground-based study. Now, we know that in space, microgravity is also inducing by itself, the fact that you have in microgravity induces also a deprivation of your immune system. Would that mean that the combination of and being in isolation and being in microgravity would kind of like double the effect of the deprived immunology, or do you think it's kind of like the same? It's just a decrease. What is your vision on that?
A very good question, Flores. So our data and also data from our European and American colleagues showed that there is a huge impact during the spaceflight on the human immune system. So one of recent research showed that immune system parameters characterizing the immune system decreases 2, 3, 4 times more than in common life. But it's very difficult sometimes to compare the results from ground-based analogs with the space flight, because we have to deal with individual data. If we have one guy who could participate in the ground-based experiments as well as on the ISS, it would be very good to see how it reacts on the whole spaceflight factors, including microgravity, radiation, and so on. And in compared to the isolation experiments, for instance. But in general, I can answer that spaceflight has much more impact on human immunity than ground-based analogs. I think that sometimes changes that are observed during the spaceflight in common, like I can say that they are sometimes 2 times greater than in space analogs. But also it's very interesting that even during the spaceflight, we see that the data doesn't go from the individual range, from the clinical range of parameters. So there is a clinical norm for different parameters, but we usually do not observe this. But it's also very interesting that during the spaceflight and ground-based analogs, we recently have published a paper about disease in the isolation experiments. Also, there is a great work done by Dr. Brian Crucian and colleagues from NASA. So there are a lot of, I would say, diseases during the space flight that are connected with reactivation, like of herpes virus infections. So then we can observe rashes, cold sores, and so on. So, for instance, reactivation of herpes virus infections happens during the space flight 2 or 3 times. I would say more often than during life in just common conditions on Earth. But as I've told you, that from the clinical side, the parameters doesn't exceed the clinical norm. So that's very interesting. And in our opinion, we have like an individual corridor of range of parameters characterizing the immune system. And if we exceed this individual corridor or range of parameters, so we can observe the reactivation of different infections. And this is a danger zone for human organism. In this way, we talk about the personalized medicine. So we go, I would say that space medicine, space immunology deals with the personalized medicine, and we need to know the data in the baseline period. So it's my favorite example which I give to students. If we have, for example, 8 billion leukocytes, is that okay or not okay for a human being? From the clinical point of view, it's okay. But from the individual point of view, the range of parameters could be 4, 5 billions of cells per milliliter, but never exceed this range of parameters during the common life. And if we have 8 billions of cells, it could be a sign of starting inflammation, and we should think about some medicine to be implemented with this particular man. So that's very interesting.
If I may allude to that, um, I think we have to rather think in changes instead of normal or abnormal values. When we are investigating the brains of astronauts and cosmonauts, we saw that the ventricles are inflated after space flight up to sometimes 20%. Initially, these results were received by many people, particularly at NASA, that yes, but it's still within normal range, which is totally correct. If the values of parameters would be going to abnormal range, then the whole space experiment would not be ethical anymore. So it has to be all ethically okay, and because you are not allowed to put people into situations where their measurements and their values of different biomarkers are becoming abnormal. That would not be an ethical experiment. So it stays within normal range, but we have to look at the differences, at the deltas. So if after the experiment a certain variable has increased with 20%, even if that is by itself a normal value, the 20% increase is not normal. And therefore, I think we now have to the advantage of measuring more and more and more data, then we can the fluctuations become let's say the signal becomes stronger than a noise, and then certain effects are emerging. And to my opinion, the recent years, the science has evolved a little bit of how we have to look at the astronauts and spacefarers in general, to look more closely for the subtle effects, because by having more people, we can definitely extract much more information about what is truly ongoing. So we are making a little bit of a paradigm shift in the minds of scientists worldwide. And also now at NASA, they definitely recognize, yes, it's the delta, which is definitely important.
Thank you, Floris. Thank you, Sergey. Anything to add on this subject?
I totally agree with Floris. So, as I've told previously, we examine first of all a human being, an individual human being. We talk about the personalized medicine. We can see delta of different parameters characterized not only immune system, but brains, but kidney, everything. So this is not okay, and we need to think how to prevent this delta, to keep all those parameters in individual range like in common life on Earth.
Yes.
When we do research, prototype research on the ground or research in space, it's all about life on Earth. The goal to achieve birth of the first human child in space is driven by the passion to preserve life of humans as biological species in the universe. At the same time, all the space research is dedicated to maintaining current life on Earth. There is a lot of technology transfers, spin-offs, spin-ins. So how is actually the current research helping the scientist to think of other remedies which help us on Earth today? How does it translate into our life? Dr. Ponomarev already spoke about immunology research. We all know how seasonal colds affect us all. This is basically immunology. It translates into the daily life. Sergey, is there something else you can give as an obvious example I haven't thought of, but it actually is so regular for everybody who is living earthly life, what's happening in the isolation?
First of all, I'd like to say about the, I would say, extraordinary results that were obtained by Professor Kozlovskaya. So, because when we talk about space medicine, and of course, when we talk about influence of spaceflight factors on muscles and bones, so we need to think about some countermeasures that will preserve muscles, bones, and so on. And so then, of course, when we talk about these physiological systems, of course, they are very closely connected with the nervous system as well. So, and her ideas about the implementation of special costumes, called reagent that is used in medicine in daily life. So it helps people with some brain injury to recover faster than without this special costume. It helps some children with nervous disease to recover, to learn how to walk actually, as well as it helps cosmonauts to recover faster than during the after the space mission without these special countermeasures. Then, of course, we have some myostimulation, and we are still working. Dr. Timilovskaya is now leading research in this field in our institute, who is implementing muscle stimulation, which helps also to better recover, as well as it could be used in clinic. If we talk in general about space medicine and space conditions, there is I think a unique, like SS is a unique laboratory for growing cells in spaceflight conditions because we, of course, lack gravity. And due to this, we do not, if we build some constructions so for the future missions, like, growing the whole organs even. So we do not need to add some special substances to preserve the structure of the cells during the spaceflight in microgravity conditions. So it's very beneficial because all those substances, which helps to prevent to preserve the structure, also has a great impact on the cells. So it kills the cells, and in microgravity conditions, it's much more easier to grow cells in space. So there are a lot of experiments that are going now. I know from the United States, there are some experiments with those 3D or sometimes 4D just for the made, and they do not need to add some substances, just put in all those necessary substances for cell growth in the first period, and then there's no need to intervene from a human being during this process. So, and also it's very beneficial that we see that sometimes cells grow in microgravity conditions faster, and it's good to test some anti-cancer drugs. It's this research is conducted by NASA scientists, also on the ISS. So it will help life on Earth to better, of course, cope with this extremely dangerous disease, cancer. So of course there are some other things that like virtual reality that is developed, like a physiological countermeasure for cosmonauts to help them feeling that they're on Earth, like they could go to different museums or to very beautiful places, forests, lakes, climb on the mountains and see all those pictures. This also could be implemented to clinics where I would say there are some people, disabled people, unfortunately, with some nervous disease. And of course, it's a good question. What was the first, like a question of egg and a hen? Some technologies of distance surgery, like Da Vinci robot. So some say it was being developed first of all to the space. Some say no, not for the. It was developed on the Earth. I mean, the first idea, but I think that the ideas of distant and telemedicine was developed thinking about the long-term space missions. So that's just some examples.
Okay,
I think
so
Floris can add much more about this also.
Well, not to,
Floris?
to a certain extent. There are a couple of indeed telemedicine experiments or let's say practices who have been invented initially for space missions. But when the pandemic was actually appearing on Earth, then a lot of these telemedicine applications suddenly gained a lot of impact and importance. And then they stayed on because now they have been seen that they have been proven to be valuable. this meeting actually is also an example of not telemedicine, but at least a virtual,
Telescience?
yes, a virtual platform where we can meet from different parts of the world, and we're being watched by different parts of the world. And that got really a boost during the pandemic because we had no other choice. And that's the same what happens when you go to space. You don't have a choice. You have to just adapt to the realities of the system. So telemedicine has gained, let's say, was indeed initiated for long distance issues like indeed space flight. But sometimes there needs like a terrestrial boost to make it work. And I think that's the same happening now with the more and more commercial space flights and the fact that more and more people are getting interested. If you watch just the scenery on the street and the publicity for different products, it is amazing how many times now astronauts, cosmonauts are being depicted in a picture for promoting coffee or other things, or just it has become a very prominent factor in our daily life these days, which was not the case like 10 years ago. Then it was much less part of just normal publicity for a smartphone and anything that was out there. So space is becoming much closer to the daily life, and definitely the commercial and tourist space activities are boosting it. So which means that we have to work harder to come up with better countermeasures to prevent let's say, the less trained people and less athletic people who also go into space nowadays, to preserve their health. And definitely the studies which you're doing, which is being conducted also by our lab and other labs regarding countermeasures and physiology of the human system in microgravity are needed to preserve the health of these short-term flyers, even if it is short-term. But if you're going for 2 weeks or in space, but your health is not the same as these well-trained cosmonauts and astronauts, then you can still have issues. But okay, that was just a side remark.
A question for $1 million, which I ask everybody. If you had a chance to go to space, would you like to, Flores?
Yes, for a short trip. Let's say
how short is short?
Yeah, I think 1 month should be fine.
1 month. 1 month is
month,
short.
2 months.
Wow.
I once remember an astronaut who I was speaking to, and I said, how was it in space? And he said, you know what, after a couple of months, you have seen it. Then you had still to do a couple of more months. So it's, I think 2 months is definitely a good, I think you need 1 month at least to adapt, to really get used to the system. And that's what many astronauts tell me and cosmonauts. Okay, it takes the time until you adapt. And then I think the fun starts of knowing how to deal with this microgravity. And by the time your brain is blowing up, you come back.
Okay, what about yourself?
2 months would be fine.
I would say the same. So the same period, because for long-term trip, I am definitely not ready. But for a short-term trip, it will be very good to fly and to experience all those extreme factors and microgravity, of course, first of all. It would be fun, I think.
Interesting. The other thing I would like to ask Floris, because we discussed what a prominent scientist he is, but one thing I forgot to mention is he is also the head of an artificial gravity laboratory in the University of Antwerp. And artificial gravity is, of course, one of the parameters which Asgardia is studying in order to see how to achieve long-term habitation and birth in space. So I also would like to ask Professor Wout to give us some general remarks, because probably most of our viewers are relatively new to the subject. So what are the considerations related to the artificial gravity which absolutely need to be taken into account when preparing for such a daring mission?
Artificial gravity is absolutely a must to, let's say, to create life. It is, I think, well, as you may know, throughout the billions of years of history on Earth, the detector of gravity in very initial cell structures dates back from 670 million years ago, long before there was a detection of motion, and even like 400 million years before even the detection of sound. What I mean is you have the inner ear in mammals, and the inner ear in mammals is responsible for indeed hearing perception as well as the detection of motion. Detection of motion means rotations, left, right, up and down, like this. These are the rotations. And this system is measured by the semicircular canals in the inner ear. Long before that, there's also another part which is detecting the gravity, the direction of the gravity vector. This is the gravity vector. When it is not Earth vertical, our inner ear detects that we are shifted with respect of the Earth gravity vector. That system dates back 670 million years ago, which means that it is so fundamental, gravity is so fundamental for human life to develop, to know where is up and where is down, that we can't go into space and create a human child, an embryo, in a microgravity environment, because we don't know how the cells will proliferate. And that may be very challenging, and I think we are not there yet. So we definitely need gravity. Big question is, how much gravity do we need? You can say, even if you have already 0.1 g, it may be enough, because at 0.1 g, things fall down. They will fall down slower than in 1 g, but they will fall down. But is that enough for cell proliferation of the human body or even of animals? We don't know. 1 g, more than 1 g, we definitely don't need. So the big question is, what do we need? And there it is very interesting to know that moon gravity is 0.16 g, Mars gravity is 0.37 g, and 1 g is on Earth. So we have like 3 levels, and if we add 0 g, we start having a kind of like a dose-response curve. My belief, my conviction is that if we would have like 0.3 to 0.4 g for centrifugation or for artificial gravity, that should be already detectable. Just having a very slight information. A very interesting experiment in this case is the following. If you have no vestibular system at all, if you're deprived of a vestibular system or detection of your balance, a kind of like a model would be that you're totally drunk. Then you don't have also a very functional vestibular system. If you ask somebody to stand with the eyes closed who has no vestibular system, he will just kind of like fall or to one side or another. The same when you're really drunk, you may fall to one side or another. But it's only necessary that you just touch very softly a support face, a support surface. Just very slightly touch a table or a wall. That is enough to keep your balance. You don't have to lean with your entire body on the wall to keep standing up. So a fraction of the sense is already sufficient to maintain your upright position. And that's why I think if we put effort in artificial gravity, we don't have to go that far that we have to make such big systems that you need 1 g, but you can also presumably have enough with like 0.3 or 0.4 g. There is an experiment discussion that 0.16 g lunar gravity may be sub-threshold, and that has been shown by the astronauts who were on the moon in the 70s, and they were driving with their rover on a tilted on an edge, actually, on a tilted edge, and they had no clue that they were so much tilted. And so they were definitely not aware of this tilt. That's for the authors of this paper, Erik Groene is one of them, a implicit core or reason why that the whole moon experiment was definitely not a fake experiment, but they really went to a moon because person who had invented this experiment in a fake situation would have never thought of the fact that there would be like subliminal sensation of gravity for moon gravity. Okay, that's a side. Now, in any case,
That's an excellent remark. I really can't believe in this day and age there are people who not only doubt that humanity went to the moon, but there are seriously people who think that the Earth is flat. But isn't it beautiful? It takes different people to make the world. But back to our boring scientific business, where the Earth is a ball and the team of brilliant astronauts have landed on the moon in the 70s. We continue discussing, however, ground research, which helps people to go even further. We have a few comments from our viewers. First of all, hello to Ariadna Gallardo. This is an Asgardian member of Parliament from Mexico. She is sending her greetings and wishing all success to the science team who is working on all the undertakings. We have a question from Serge Colin, also an Asgardian member of Parliament. Sergei, probably to you. Can you give us your feelings about the team's behavior? How did you personally experience this experience? I'm not sure. Have you actually yourself been an isolation experiment? I didn't know if you were.
I think fortunately not.
Unfortunately, no. Okay, so
Fortunately.
not about your personal experience, but rather as a director of the program. What's your current view? How is the team from the human standpoint undergoing this extraordinary experience?
That's a good question. First of all, I'd like to admit that my wife has participated in the 4-month Sirius missions, and I have her impressions about the experiment. So her impression that when you are situated in the isolation, after 2 or 3 weeks of the experiment, you get adapted to these environmental conditions. You forget about the external world. You are concentrated on your inner world, only in your experiments, and sometimes after 3 months of the isolation, for instance, you can even doubt that there is a huge big world. You remember it like a dream because your world now it's very, very narrow. So all those experiments are very close to a real space mission. This what I've heard of from real cosmonauts who participated in our experiments before or after the space flight. So I can say that besides of microgravity, you feel the same. So very similar environment. So it's artificial environment in this experiment, like in the ISS. Then I would say the construction of our station is very close to the space station, so it looks like the same, except of maybe some details of interior in this our chamber. Then, of course, the interaction between people. We still explore the human behavior in our experiments because we still get statistics, and each crew is unique, I would say so. And the interaction between people could be very, very different. For now, in this experiment, I can say that they are acting like a crew while conducting some experiments, but during their leisure time, there are some individuals who separate from the other team. They go to their cabin and enjoy their loneliness, reading books or watching movies. But some of them are playing different table games and spend time with them. So it's really interesting to explore this. And of course, I can say that, like in each experiment, there are some conflicts. They are mild conflicts. And those conflicts could be between crew members and between crew members and the mission control center. It depending on the situation, and sometimes we stimulate some situations when we have an internal conflict. We are trying to implement like an external conflict to make like another source of irritation for them, and they switch their attention on the external I would say, of course, enemy. And the team in this period unites. So it's very interesting. And we still have some methods also to evaluate stress. Because, as you know, that when we use different questionnaires, we sometimes can have the not very representative data because a person can lie. He could or she could just write and to seem what he wants to be. He is good, he is okay, but he's not good and not okay. But to stay in the experiment, not to pay attention, not to seem weak. Uh, so he can just put the results, false results, to the questionnaire. Or sometimes they have no time to fill out all those, a lot of questionnaires, and they put it A, B, C, D, A, B, 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 and so on. When the researcher gets the result, he understands that the researcher was cheating. But when he tries to hide his feelings, hide his real impressions, so we have very smart people in the isolation. Cosmonauts are very smart, so they can just provide false results, and it will be very extremely, I would say, difficult to find out if they are right or not. So we implement the objective measures like analyzing of voice, so we can judge them by their emotions, their voice, so we can say and that if they are okay or not. Then analyzing of their speech, some phrases, some trigger phrases that has been analyzed by artificial intelligence also helps us to better understand and to validate the system of understanding those special patterns that helps us to understand their real condition. And of course, the video analysis of their mimics. Like maybe you remember a series, it was called Lie to Me with Tim Roth starring. So we have the same program based on also artificial intelligence, which are trying to develop in our experiments to get objective feelings about the conditions of human beings inside the isolation, then of course to test these on the ISS and in future missions.
In the Light to Me, they were having a special observation cube. Are you saying that the entire isolation facility is under total surveillance? Apart
No,
from the bedrooms and toilets, I suppose.
yes, bedrooms and toilets are not under the surveillance system, but other under it with a very good quality, so we can analyze the impressions.
Wow. So
And
good people,
mimics.
are you hearing this? Going in isolation experiment is not only being locked up with the colleagues 24/7 for 1 year, but it's also being watched by other colleagues. So you really need to love science to subject yourself to being a member of such an experiment. Another thing which comes to my mind as a ordinary person, just watching it as somebody interested in popular science, is that they are deprived of individual communication tools. On the ISS, there is still call with the ground. You can call your family. There is very weak but still internet connections. Here, to simulate interplanetary mission, the crew totally abandons their personal communication means, and their communication with the ground is simulating the delays which happen in the interplanetary flights. So from where I stand in my, in a way, primitive shoes, this would be the biggest challenge. Not that somebody watches me, but actually that nobody lets me talk to my friends. This is a major part of psychological experimentation and psychological challenge. From what you have described, Sergey, it sounds both also like psychological experiment, but also sometimes as a psychological support tool. Did I understand correctly?
Yes, it could be also implemented as a psychological support. And you're absolutely right. They are in deprivation. We are simulating interplanetary mission, but they have a possibility to communicate via emails with their friends and families twice per day, in the morning and in the evening. So they receive letters from, but they can't talk directly, and it's very challengeable. That's what also I've heard from my wife, that it's very hard to not to listen to your friends, family members, and it's very hard to not to feel the nature outside. So some things, some little things that you're not paying attention in daily life, smells, wind, sometimes thunderstorm, it becomes very important in the isolation. You miss it very much.
Can I be cruel and ask you, were you in her list of people she missed talking to for 4 months?
Yes, I was.
Okay, I'm not so cruel then after all. We have more questions coming in. Are there any missions planned featuring animals procreate in space? Not fertilization, but actual birth in space. Is such a mission going to be a step towards first human birth in orbit? Is there anything like that planned as far as you know on the ISS, Floris, Sergey?
Well, there's definitely work ongoing in this evolution, and I just have opened the paper on PubMed in Nature publishing group Microgravity, which is a very renowned journal about microgravity. And in 2023, apparently there has been a European perspective, a white paper published by ESA, stating human development and reproduction in space, where a lot of important variables are being discussed and shown, for instance, that there is definitely a difference between male and female reproduction systems in space, just evolution, how it goes. I know that there are a few experiments in the past where, for instance, rats semen has been sent into space, and then when it came back, it has been used for fertilization of other rats, and there were some contradictory results which are sometimes successful and otherwise not successful. So, as far as I recall, there has been not a uniform answer there yet. But what is important to realize that at this stage, that whereas a couple of years ago it was not entirely taboo to talk about reproduction in space, but it was a topic which was not really on the plate of many institutes or space agencies. And now, the past couple of years, it has really boosted also enormously, and there are many more people who are really investigating this concept of fertilization, going to space, giving birth, and that type of thing to investigate. So this is definitely, well, I'm not sure if they follow the drive of Dr. Igor Azhebeli, who came up with this idea already several years ago, but definitely the scientific world is following up and more investigating efforts in this on this path. But I don't know specific of planned missions for the near future about animals sending up into space, for a simple reason that, well, sending animals into space is a cumbersome thing. I don't know if you ever have been in an animalarium at the university, for instance, where the animals are being kept for other investigation studies, etc. But it is very smelly in such an environment. And now, on Earth, we can open the windows and the doors to get some free air, but that's something which you can't have in space. So just introducing animals like rats and mice in space beyond snails and spiders, because they have been and frogs, they have been in space, and fish also. But rodents is a different story. So that is a very big challenge to do it to keep it in space. For short duration missions, again, that's a different ball game. If it is only like 2 weeks, then you can have this like rack with animals in space for a while. But when you're going for 6 months durations, then you are there with 6 months for these animals, and you can't just walk them around and let them. So it's on paper, it's a simple experiment, but in reality, it's a much more complicated thing for many reasons. And that's actually one of the questions I had. If in the isolation study now at Sirius, is it also smelly inside, or are they able to kind of like refresh the air once in a while? That was just a question I had for their internal situation with 6 months.
I would say it's a bit smelly, like on the ISS. We still can't avoid all those vivid range of smells in the isolation. And you're totally right that rodent experiments will bring a lot of challenges on this, and maybe biosatellites could help us to solve this problem.
Yes.
Yes.
From what I've heard on the ISS, it's by far better air than it was on Mir Station. Is that true? Because Mir Station, of course, was much less modern with much less circulation.
I have never been to Mir Station or to the
Or
ISS
to
station,
ISS.
but I've heard the rumors, I would say, yeah.
Well, it makes sense if you think about it. And Sergey, any remarks from you on what Floris just spoke about animals and space reproduction plans?
Well, just a couple of words. I would say in general that experiments with humans and on animals work hand to hand all together. So we can't conduct some experiments with human beings to the ethical issues. And on the other hand, there is a very great psychological factor which is very important to human beings, and it's not very representative on animals. So all those experiments should be done in parallel. And I think that planning, of course, childbirth in space, we should do this first of all with animals and to see how it will work, but we should consider a proper platform for such experiments, as Forrest has already told. There are a lot of challenges with those experiments on the ISS, for instance.
Well, the real birth of the human child in space is, of course, quite some years away. So we don't know yet if it will be natural birth or if it will be an artificial womb. The thing is that it's a conception of a real human embryo, and the birth is achieved in whichever way is then deemed best by the scientist in the condition of artificial gravity in space, probably most likely in the low Earth orbit the very first time. Asgardia held in 2019 a scientific conference where the scientists from all over the world who specialize in these matters got together in Darmstadt at a time. We are looking to hold the next conference tentatively in summer 2025. Professor Floris Woutz, as the Minister of Science of Asgardia, will again be the lead of this conference. So we expect that towards the end of this year or even sooner, Asgardia will be publishing news announcements about this upcoming conference. And we, of course, together, first of all, with our great partners from the Institute of Biomedical Problems, will be preparing a big program related to everything to do with human physiology in space, including achieving birth of our first child in space. I remind you that you can read more about Asgardia, about the webinars and the core people of Asgardia on asgardia.space. Professor Dr. Floris Woutz, Minister of Science of Asgardia, Dr. Ponomarev is director of the Sirius experiment, where Asgardia is a partner, and Asgardian crew member Dr. Ksenia Arlova is participating as a lead scientist and a medical doctor in the female health research in long-term isolation. I'm Lena Devina, Prime Minister of Asgardia. Please follow our news on asgardia.space. Please watch us in webinars, follow the announcements of the webinars. We love receiving your questions. We love seeing you watch Asgardia TV. Dr. Ashurbeli has founded Asgardia on 12th of October 2016 and building it out to achieve better life and preservation of life of the humans as biological species in the universe forever. Join us and follow our news, asgardia.space. Thank you very much, dear colleagues. Thank you, everybody who watched us. Have a good day, morning, and evening, and we see you soon again.